Hey, thank you everyone for joining us today for our Optimizing Your IBM I Availability Storage versus Software Replication discussion. I'm Bill Hammond, Director of Product Marketing here at Precisely, and I'm joined today by Dan Sims, who's our Product Management Director for our Assure HA product line. And we're here again to discuss this topic about evaluating storage versus software replication. A couple of quick notes. This presentation is going to be recorded, so don't feel like you have to take exhaustive notes. You will get a copy of the recording, and once you have it, we encourage you to share it with your colleagues and anybody else that might be interested. So with that as a bit of a preamble, let me get into how we're going to frame our discussion today. So I'm going to start off and talk a little bit about, defining what data replication really is and why it's such an important consideration, just in general. And then I'm going to hand it over to Dan, who's really going to get into comparing the replication technologies that are available specifically for IBM I with an eye toward the things that are really important for those IBM I users, people running power systems and running IBM I on those systems. And then we should have time for at least a few questions at the end. So getting into the topic here real quick, this defining data replication. The way that we think about data replication is it's that creation of multiple copies and maintaining those identical copies. So you've got one primary copy, you've got an exact replica backup copy of it. And those copies can live on the same system, across a different system. They can live in the cloud. But it's having that additional copy of that data, that piece of data. So what that will give you is that it ensures that if you have an outage or a reason that you need to get that backup copy, that it's always available. You've got your data in more than one place, which has a number of advantages that you'll see as Dan gets more into his. But data replication, it's really crucial for making sure that you've got resiliency, you've got consistency of your data, and it's just become a part of really modern computing environments that you really need to be thinking and taking advantage of the replication technologies that are available to you. So why is that so important? Replication is something that, it's been around. It's not a new technology, but it continues to be very, very important, largely in environments where they're running mission critical systems. If you're running a mission critical system and you've only got one copy of your data or even your application, and you have a problem, now you're looking at downtime, and it could be pretty specific downtime. So even when you think about technologies that are something as simple as backing up, backups, whether it's tape backup or disk to disk backup, all the high availability solutions, anything that's considered DR, those all rely on replication. They all rely on taking a copy of the existing data as it is and then making a copy of it. Differing degrees of replication have to take place. The backup is kind of a one-time shot, and you take a backup copy of it, you've got a copy. But when the item changes, now your backup copy's out of date. The HA and DR solutions tend to lean more into closer to a real-time replication scenario. So if the item on the primary system changes, we automatically change that item on the secondary or replicated system as well. There are a number of different ways of going about this, different technologies, different approaches, but that all of those approaches and those options can have varying degrees of performance impacts. How long is it going to take you to get back if you do need to get that secondary copy? How long is it going to take you to get that? So that's kind of recovery time. And then depending on your computing environment, how flexible your infrastructure either needs to be, or how flexible your replication solution needs to be to live inside of your particular infrastructure. So when we look at storage-based replication versus hardware-based, and against software-based, again, these are the two different, primarily the two approaches to replication in the IBMI space, but honestly across really the whole spectrum of computing. So when we look at them at a generic level, what are the pros and cons of each? And then Dan's gonna, and I turn over to him in a few minutes, he's gonna step into the pros and cons specifically for IBMI. But generally, when you're looking at software-based replication, these are products that you've probably seen, VMware, Veeam, those kind of products that are out there, and they're managed at the OS level. So software-based replication is more, at the OS level as opposed obviously to the storage level. Some of the pros there in that approach, the hardware is agnostic. You don't need to have matching hardware to do software-based replication. It's a little more friendly if you're going to involve your cloud environments in that as well. Flexibility in terms of what you're replicating can be much higher in a software-based replication environment. There can be tremendous cost efficiencies around software-based replication as well. And software-based replication can be application aware. So if your application is having a problem, we might be able to know that, where storage-based replication may not know what's going on with the application. Some of the cons, depending on the technology here, you can have overhead network bandwidth and things like that, depending on the solution. It's not something that actually we run into in the IBMI space, but it's a possible thing. Latency, sensitivity. So if you're making a copy of the item on one system and you're getting it over to the other system and it takes a while, that's latency. Complexity of implementation can be a potential conflict or a potential downside. And then making sure that everything is consistent on your primary and your backup. Your software replication solution needs to make sure it has error handling and consistency checks or auditing to make sure that those two systems are in sync with each other. Now, from a storage-based replication, again, some advantages. It can be fairly high performance and get things from one storage device to another storage device relatively quickly with minimal impact on CPU. They can be generally reliable, sort of once you get it set up. You don't have a lot of things that you need to do to it on an ongoing basis. And it can support synchronous replication. And that's simply stated as, when I have a change to an item, I don't actually fully commit that change on my primary till I know I have a backup on my secondary system. So I wait and make sure that those items are both in sync at all times. From the cons, you can have vendor lock-in in terms of storage device talking to another storage device. You don't have a lot of flexibility to go between vendors or even between models within the same vendor. Flexibility of what you can replicate and how granular you can get, which is another limitations on the storage-based side. Costs can be higher on the storage-based side. That's really largely a situation of what solution do you pick. So it's not always more expensive or whatever, but it can be. And then it is not as cloud friendly a solution, because you're talking about a physical device to a physical device replication, than the software-based approach when you get into cloud computing. So those are some of the generic high-level pros and cons. In the light of those, what I'm going to do now is actually ask Dan to take control of the slides and push into this concept of IBMI specific conversation around storage versus software rep. So Dan, take it away.
All right, thanks a lot, Bill. And that some of the things that Bill we're talking about is kind of the broader industry definitions and how people use software versus storage replication. But here we speak and breathe IBMI, right? And so we really want to dive into the specifics about running an IBMI system when it comes to software versus storage. And the reason why we do it is really for resiliency, right? And so we at Precisely, me, a product manager for Mimix and Itera and QuickEDD, we love the IBMI system. It's an absolutely wonderful system. It's the best system out there. We promote it. We're big IBMI enthusiasts here at Precisely. But on the other hand, some of the storage replication-based HADR resilience may really not be the best thing for you. That that you're being told about out there. So to protect yourself from system downtime and data loss. So be careful about that. And so this presentation is going to be very IBMI specific, and we're going to get into um, the nuts and bolts of why I say that. And so really, you need to step back and think about what it is that you're trying to avoid, right? You're trying to avoid downtime and risk to your business, right? You're trying to avoid these things uh, to your production application. So bad stuff can happen out there, like damaged objects, like access path rebuilds, unknown recovery times if you do take an outage, reclaim storage events cause downtime. And when it comes to higher risk, when you're trying to do an OS upgrade, well, what happens if that doesn't work very well? You got to go back plan. That's a risk to OS upgrades are a risk to you. Um, just having systems available to service users is a, or not available, or the potential single point of failure of a system is a risk to you. So having options to workload balance is something to consider. Uh, if you depend on flash copies, or you think that's going to be something to help you with that, what about dirty flash copies? That's a risk. Abnormal, are you exposed to abnormal IPL? And does your recovery plan depend on abnormal IPL or abnormal Variana devices? That's a risk, right? What about incomplete space coverage? So these are the things you really got to step back and say, what is it that I'm really trying to do here? When you're evaluating some of these resiliency technologies. So I thought we'd have a little fun here today, and lighten the mood a little bit. Some of this stuff can be a little esoteric, but here we have a nice image of some good-looking kids, and we all love our kids, right? So uh, think of that image right there as your production output. So think of it as, you're taking pictures all the time. We all are. Think of that photo image as your production output right there. Okay, it's rare, it's there, it's intact, it looks good, it's clear. And in this example, we're running LPAR A on a production system, Power 10, and it's has an external storage device. All right, so the LPAR images, the volumes of the LPAR run on the external storage device in this example. Now you could run them on internal storage devices, but I specifically called them out here for external storage because that's where storage replication lives, okay? So now when we're talking about logical replication, if I want to add a backup LPAR to that, LPAR A, I would add LPAR B on another Power 10 system, right? And that could be, across the country, it could be on the same data center, it doesn't matter. And I specifically noticed the purple and the blue there. We've got OS 7.5 and IBM just released OS 7.6. So we can span that. We can replicate from a lower to a higher OS level, and we can do the reverse. We can go from a higher to a lower as well with logical replication. And you have that backup copy there, and as you can see, the image is the same on both systems, but they're two distinctly different LPARs. They're two distinctly different images, and that gives you advantages like being able to run your higher level OS and replicate from a lower to a higher. Now let's compare that, adding that backup system with a storage replication orientation, okay? And so now we have LPAR A on the left, and we're replicating that image to uh, to the Power 10 backup system. But notice it says LPAR A, but it's offline, right? What is that all about? Well, that LPAR is unavailable to you. Unlike the previous slide, you can go see that and you can audit it and do things with it, but not in a storage replication environment that is completely unavailable to you, because the storage devices are just replicating those volumes at the volume level. So you cannot mount that, you can't IPL it until you have turned off your storage replication. So that's what it looks like there. So that, obviously you can't have different OS versions, especially if you're doing full system storage replication, which I'll talk about in a minute. Um, so let's continue here. Now, what if we want to do a plan switch over? Let's say we want to go ahead and run on our backup system. Well, for logical replication, you can see it's pretty simple maneuver. You just shut down the application on A and bring it up on B, right? The important thing is that the B system is already there. It's already intact, ready to go. And in this case, we're actually jumping an OS version. I just show that for an example. Of course, more often than not, you're going to be on the same OS level, but this is a way to minimize downtime. I'm going to talk more about that later when you do an OS upgrade. And so you're simply operating in reverse now. LPAR B is replicating to LPAR A. Now let's take a look at a planned switch over with our storage replication. Now remember, LPAR A, the image over here is it's the one thing I meant to speak to on the previous slide with the storage replication was that if you notice how it's a little pixelated here, okay? So what's the way that storage replication works is you're transmitting sectors of disk, right? So it's always going to be sort of you might change some bit within a 4K sector and you're going to transmit the whole 4K over. So it's not exactly the same over there on the backup system. So when you do a switch over, what you're really doing is you're doing a recovery. So you're IPLing the system. Now, if you're doing an independent ASP, you're doing a Varion. If you're doing a full system storage replication, you're doing an IPL. So let's go ahead and see what happens. What the system does is it actually goes through a recovery. Bunch of steps there. You see them, there's 34 steps, and a whole bunch of those are recovery steps. So it went ahead and it corrected that image, it recovered it back to the way it was, and now we're intact again, and our image is clear. So you can go ahead and now run the production server. So, and that's fine for a plan switchover, although you have to go through that 34-step process as opposed to the logical replication solution where it just it's already there. But now we get into a production system crash and recovery. And so I'm going to compare this first with the logical replication. Well, so you can see the system on the left is a hard down. It's gone, right? Now, systems do fail, right? So don't let anybody tell you that systems don't fail. Let's live in the real world here. Power systems can. Now, they're extremely reliable, but they can fail. But now you have all these moving parts. You got these storage devices. They can fail, right? Or network data centers can fail. Who knows what can happen? So let's not pretend that, one system it doesn't fail, because it does. And we see it all the time with our support line, and we have to deal with it. So with logical replication, as I said, the system is already there. The image is intact. It's ready to go. So you just perform an unplanned switch over to it. And it's as simple as that. System on the left bad, system on the right good. So let's run on the good system. Now, if we compare that to storage replication production system credit, remember we started out pixelated there. We started out where the image is not exactly the same. And so let's go ahead and we have to run a Varion or an abnormal abnormal IPL. You're exposed to that. Remember, we said you're really recovering the system back. So now you have to do it in an abnormal circumstance with storage replication. And so let's see what happens. Let's go ahead and run this. So it's going to take some time, right? And this is the time window for this is unpredictable. Okay, you don't know how long this process is going to take. So it's in the process of recovering our image. But what's happened here? Things aren't looking good. I'm sort of getting nervous now, and the manager wants the system back up. Okay, the IPO is done and the system's up, but my image doesn't exactly look like what I expected it to look. It didn't look like, I don't know what's happened here. So that what you see there, we lost a couple of our kids, and That's damaged object. That's the potential for damaged objects. And I'm going to talk about some of the reasons for this, the potential for this. Now, um, the other thing that you could be exposed to is access paths are no longer built. So remember, an access path is an index for how to access all the data. You might have millions or billions of records out there, and you have those indexes so you can rapidly access records. You might have lost that and you have to rebuild that. So that's going to take time to do as well. So your image might not be exactly what you expect it to be in an unplanned scenario. You might have some damaged objects. The only way you can fix damaged objects is to delete them and restore them. So now you're having to go to tape and, oh boy, when did I take that last tape? Is it accessible to me? Um, is the data even in sync? Did I lose any change? What did I lose? So now you're doing a lot of head scratching to recover from those damaged objects. So I hope that was a little fun, going through this. But these are trying to illustrate this point about what can happen in a planned and unplanned, and the risk and downtime that you might run into. So now I'm going to explain some of the details of how why I say these things can happen. So some technology considerations we're going to dive into here is the underlying architecture, replication and recovery point, online or offline target, application data requirements, damaged object replication, access path recovery, topology flexibility, and bandwidth usage. So these considerations are very important, and we're going to follow it up with some real world scenarios that can happen out there. So let's start with the underlying architecture. So the storage, with storage replication, the storage subsystem, as I mentioned, the storage devices are the ones who are actually doing the replication. It's not the power system. It's not the OS. It's in a separate device, right? So sectors are written to the source SAN, are replicated to a tightly coupled target SAN. Now this is very important here. You've got a distinction here. You've got an IASP orientation and you got a full system. And you need to understand there's two different ways to do this. You can have a independent auxiliary storage pool orientation where you basically have storage replication for your IASP. So on IBMI, you've got ASPs 1 through 32. Those are the system ASPs, right? And then once you go to 33 on up, those are independent ASPs. And what's an independent ASP is it's an auxiliary storage pool that can be started and stopped and switched independent of the operating system. So that's why they call it an IASP. And if you want to achieve it, IBM will lead you with an independent ASP if you want any kind of serious resilience. The full system, on the other hand, basically just means just mirror all of the storage volumes of the entire LPAR, right? So you're mirroring the operating system. That's very important to understand. The operating system that's changing all the time, you're mirroring it. And then, of course, guess what? You're mirroring the operating system, so you don't get to have different operating system version levels. So forget that. All right. So when you do a switch, it's done by attaching the storage to a secondary server and recovering to that server. I mentioned that earlier. It's all about doing a recovery. Okay. Now, if you compare that to logical replication, Assure mimics here precisely. We use remote journaling to provide the underlying replication mechanism. That's done at the OS level. It's server to server replication. It supports internal, external, or mixed storage. Replicates applications and data from sys-based ASPs, user ASPs and independent ASPs. Data is replicated at the end of the transaction. So that's a distinct difference. It's not a sector, but it's a journal entry. So a transaction boundary is when it replicates, and then you can switch to a live target without any recovery steps. Okay, so that's the big difference right there. This storage replication is a recovery to that server. Is logical replication, Assure mimics is you have a live hot system available and ready to go. Let's talk replication recovery point. So the data may be, this is an important, the IBMI has extremely high transaction processing capability. It's a wonderful transaction processor, and it does that by having data in both memory and disk at the same time. So it's constantly being moved back and forth, flying around to support your application. So data is not protected with storage replication until it's written to disk. So you don't know when that actually is going to happen, right? And so one of the things you really should be doing, all IBMI users should be running journaling. So don't get any ideas that you don't need journaling because you got storage replication. Journaling is your friend, and that helps you recover from when bad things happen. So journaling does help save data to disk before each transaction. So that is favorable and helps the situation and provide some transactional integrity. Mimics, on the other hand, journaling eliminates issues associated with delayed disk writes due to memory caching. Okay, so that memory caching is where the data is flying around in memory and not flushed to disk yet. So journaling eliminates that. So journaling saves data to disk before completion of each transaction, and remote journaling provides zero RPO. You can have a synchronous mode if you want it. So don't let anybody tell you that they're getting, you can only get synchronous with storage replication. That's not true. You can get synchronous with synchronous mode remote journaling, which we support. And you can also have asynchronous remote journaling, which is actually gives you sub-second transmission without having to go to synchronous mode. And synchronous mode, you better make sure you've got a good network or your application is going to be affected. Let's go to the next one here and talk offline or online target. I did mention this in the earlier part of the call. So remember that it's really simple here. With the storage replication solution, the target is offline. It's not available to you in any way, and it must be varied on or powered up in order to use it. Okay, so some users might add a point-in-time copy to storage replication in order to access it, like flash copy or some other snapshot oriented technology, which is fine, but it's a point in time. Okay, it's a point in time, and it must be varied on. So you take your flash copy, you take your snapshot, you got to go ahead and vary that on or IPL it to an entirely different LPAR in order to use it. So that's pretty inflexible. And not only that, it's subject to dirty flash copies. So it's really not a great plan if you need to provide your users real-time access to a copy of the data. Mimics, on the other hand, the backup server is always current and live there and can be used. So, and people do use it. We have thousands of customers using it for reporting. Now, and of course they use it for DR and they use it for HA, but they're using it for reporting, for DI, BI, for testing, tape saves. So many people use logical replication to do target side saves. It is such a great solution for that. And you're not subject to that dirty flash copy like the storage replication is, and more. So let's move on to the next consideration, application and data requirements. So earlier on, I talked about the difference between storage replication options with independent ASP versus full system storage replication. That I need to emphasize that to you. You need to understand what that is. You need to, if anybody wants to propose to you a storage-based replication solution running on IBMI, you need to ask them, are you going to do a full system storage, which is kind of a cheap and simple solution, but not really very good, and versus an independent ASP solution, which is better, okay, but if you're going to get to that higher level of resiliency using an independent ASP, you have to convert to independent ASP. So that's a hurdle that you need to cross. You need to convert your system and your operating environment to support independent ASP, which is not out of the box. You have to do that. So application data must reside in the IaaS to be protected by storage replication. And then uh, they do have, with IBM's solution anyway, they have this administrative domain, but that doesn't cover everything in sysspace. So the name of the game, if you're going to do this with IASP, is you would get everything you can into the IASP. But what if you can't, right? And there are things that need to be in sysspace, right? What if you have an application that requires something in sysspace, or maybe your application doesn't support independent ASP? What do you do then? So that's a dilemma for storage replication solutions, is that they have really incomplete coverage for sysspace. Now, if we go with Assure mimics and logical replication, there are no application changes required. Mimics is independent of the underlying storage configuration and can replicate from into sysspace, user ASP, IASP, mixed environment, doesn't matter. So, and we have people doing it all over the place in these mixed environments with different applications. So, much lower hurdle to get to a logical replication, sure mimics resiliency solution. Let's talk damaged objects. Now, I mentioned this in the fun little opening where we were looking at the images of kids, but it's serious business. Damaged objects are serious business. So they're just bad, right? Objects damaged on sources will be propagated to the target. So if you get an object, whether uh, that is damaged, storage replication is going to, it's not a matter of if, it will propagate that to the target system. Now, when did that damage happen? Well, these things happen at unplanned failure times, right? That's when they happen. So you crash your power system, you could get damage, and the storage device is going to replicate that damage. And now you have that damage on the target side, and it's there waiting for you to deal with at the worst possible time, right? So you're having to not only recover from an outage, but now you got a damaged object. So they're just bad, bad, bad. So they typically require you have to delete them and then go back to tape to recover them, which is going to take you time and elongate how long before the system is going to be ready. But with the logical replication solution, Mimics cannot propagate damaged objects from the source to the target system. It just isn't going to happen because by the nature of the replication solution, you're protected from that naturally. So also Mimics audits will ensure that objects damaged on either the source or the target are detected. And we have had many cases where Mimics has detected damage on the source that the user didn't even know about. And so then we would tell them, hey, you've got a damaged object on the source. And they said, well, we didn't even know that. So thank you for pointing that out. And then they would fix it by deleting it and going back to tape or recreating the object in some way. So with this, live target data is always ready for switch without added recovery steps. And then along hand in hand with damaged objects is access path recovery, right? So access paths, again, those are those indexes. If you're of the older generation, think of the phone book, right? And how do you look up somebody's name in this big, thick phone book? We do that by alphabetical order. That's the index, right? So what can happen when you have these hard down situations is that if you crash the IBMI, the access paths are going to perhaps never got flushed to disk cleanly and can be subject to having to be rebuilt, which is a lengthy process. The larger the access path, the longer it's going to take to rebuild. Some applications won't even start if the access path needs to be rebuilt. You just can't even use it until it's done. So this is a big deal. You want to avoid this. And again, that happens at failover time, unplanned failover. But with Mimics, there's no exposure to rebuilding access paths. Audits also verify access paths. So you cannot replicate an invalidated access path from source to target with logical replication. It just naturally doesn't happen, so you're naturally protected. So you can minimize downtime by switching to the target during a long access path recovery on the production server. If you were to have if you were to be in a situation where the production system had to rebuild a bunch of access paths for whatever reason, you can actually switch over to your backup, and those access paths will be intact. Let's talk flexibility of topology flexibility. So, Bill mentioned some of this stuff. Basically, everything needs to be compatible and similar. Source and target SAN, hardware source and target OS levels must be similar. There's distance limitations because storage replication uses more bandwidth. But if we compare that to logical replication mimics, um, a lot of that goes away. So storage independence, different storage devices, even different storage vendors, you have that flexibility. OS, you can have different versions of OS level and technology refresh and PTF levels, very flexible. No distance limits, it's just a TCP/IP network, and we can handle lesser quality networks. Supports broadcast to multiple targets. And let's talk bandwidth. So, the important thing here is that you have to have a very high quality network with storage replication. So that's going to be a hurdle for you out of the gate, is you better have a high quality network. And there's a couple of different modes of operation with storage replication. There's synchronous mode, which demands a very, very high quality, low net latency network. And then there's asynchronous storage replication, which can go a longer distance, but it still uses a lot of bandwidth. And as compared to a logical replication, it's going to have to be a much more quality network, or it's just not even going to work. So you don't see a whole lot of you know storage replication across the country and things like that, just because it's impractical. So um, yeah, you have to journal. Not only, remember I said those 4K sector sizes. Well, when you write to the journal, that's a 4K sector size too. So you're transmitting all that. Basically, you even think about making a change, you're replicating a 4K sector, right? So you can see pretty easily how the storage replication requires much more bandwidth and is more network intensive. If you compare it to Assure Mimics, it's just the journaling that gets replicated across the network when objects change, right? So you can further reduce that if you need to by filtering journal, like remote journal filtering, and journal optimization, journal minimize entry, data hardware compression. So these are things you can do. Uh, it, and you can go, we have customers all over the place replicating across the country. It just works really, really well. So those are the considerations. And now what I like to do is spend a little time on some common scenarios. And number 1 and 2 here, I actually already covered. So I'm going to skip those. If you go back and want to talk unplanned switch, go back and review those slides with the kids on them. But let's get to scenario number 3 um, and talk reporting. So remember that the target data is not accessible to storage replication at all. So you, on the storage replication side, your only option really is to have a flash copy solution or some alternative replication solution. Maybe it's mimics, right? So we actually have customers who are running storage replication, but they want to make use of the target data, and so they use mimics for that. And so you can run reports against the target, and the remote journaling support for broadcasting actually enables multiple targets. So you can have a DR node, you could have an HA node, and you could have a reporting node. And then when you switch that, you see those 3 arrows there on the right hand side there? When you switch that, Assure Mimics will redirect those arrows. So if you were to switch over here to the HA server, right, now your arrows are going to be going out like this, right? And Mimics will take care of the movement of those replication streams. And then you still have everything you need there. So fully accessible and highly useful to be able to read that data and know you're getting real-time data there. So target integrity validation. So the target SAN cannot be audited for data integrity. This is basically you trust the hardware. For you really are saying I trust the hardware replication because I have no other way to validate it other than testing it, right? You can do a test of it. You can do a flash copy, but then you're dealing with that whole dirty flash copy bit and things like that. So if there's any kind of corruption, you wouldn't know it, okay? If your target was corrupted. But Mimics and logical replication has the capability to run audits and do comparisons, right? So you know, and you do this ongoing to make sure that you have self-healing audits and continuous monitoring of target data, visibility into protection and audit status, right? And you can actually test it too with the virtual switch. So you can actually go into simulated production mode and test it out, make sure your application is running. But the big thing is the audits, right? So that you have, remember that system's live, so you can actually check it out and make sure it's good. So here's a big one. This is a real big one. If you're looking to really run a high availability shop, you are going to have to upgrade your operating system. And the storage replication, remember I talked going back to the running the independent ASP versus the full system storage. So let's start with the full system storage. You have no option to do an OS upgrade while active with the full system storage. So just push that one off the table. Okay, it's not a great, it doesn't do help you all that much, right? But the independent ASP you actually can. So you can actually go ahead and have independent ASP where your replication is going, and you have this system. You can go ahead and upgrade your backup system. And so now your source is at 7.4, your target is at 7.5, but you're still running on your 7.4 system. So what you're going to do is you're going to switch over to the 7.5 system. And when you do that, when you vary on this IASP it's going to convert that thing now to 7.5. That's going to take some time for it to come up. And once it comes up and you're running on 7.5 on that IASP, there is no going back, right? So you are not going back to 7.4 in that scenario with storage replication. Now, if you compare that and do that same thing with Mimics, you got 7.4 running on production, and you got 7.5 over here. You can upgrade that target to 7.5. Now you can go ahead and do a switch over to that 7.5 and replicate in reverse. Remember we talked about that earlier with the kids. So now you're running that here, 7.5 here, you're going back to 7.4 there. And we've seen this, it happens. You find out that your application wasn't quite ready for 7.5, or maybe 7.5 wasn't quite ready for your application. And so you can go back, right? So you can do a controlled switch back to 7.4. That's a big deal. That's a big ace in your pocket to manage your resiliency. So do be careful about that and position yourself to have a go back plan at all times. Let's talk storage event management. Now this is less and less common, but it can still happen. So remember, source and target storage images are tightly coupled. They're bit for bit copy. And so if you have a single system storage event, like suddenly you have to do a reclaim storage and you might have to do an IPL, that's an outage to you, right? So whereas Mimics, you still have the same situation. You might have to do a reclaim storage on your production, but you have a distinctly different backup copy image. Then you can just go ahead and do a controlled switch over that, and then go ahead and do your reclaim storage on the on the node that needs it while you're running production on the backup node. So that's a distinction there. Let's talk workload distribution. So remember, we talked about it several times already. You can't touch the target system. It's just not available to you, right? So it's read over here, read write over here, nothing. Okay, you just don't have access to it. Whereas Mimics, big difference. Here you got read write on the production system, and you've got it's active passive for write workloads. So we're not doing writes here on the target, but you are doing reads. You can do read workloads over there. Remember, we talked about queries, uh, workload distribution. We talked about target side backups. So we like to say that it's active for write. Sorry, excuse me. Active for read workloads. Active passive for write. Running this way. Active for read workloads, and they do it, and they take it for granted, but that's what's happening. And we actually forever have supported active for write workloads as well. Now that, to be fair, that does take some application optimization. So, but we have supported that for a long time. So that's a distinction. And this goes right in line with that. Backup while active. Everybody should be taking a backup out there. And it seems pretty straightforward. But it's hard to do if you've got an active production IBMI system and you've got open commit control cycles and locked objects. It might be easier said than done to get a backup. And so what people start doing is they start thinking, well, with storage replication, I'll just do a flash copy or I'll do a snapshot. And okay, that's great. You can do that at the storage device, but you're going to get it. If you have all that stuff going, open commits and locked objects and data floating around in memory, that doesn't go away just because you did a flash copy, right? So you end up with a dirty flash copy or a dirty point in time copy with questionable quality, right? And this happens. So then you have to take that thing and you have to IPL it to a separate system, and then you can run it to tape if you can get that LPAR to start up, or that independent ASP to vary on. If you can get that to happen, then you can take a backup. When it's all said and done, where are you even with this, right? You don't know. So that's the issue there. But if you compare that to Mimics, we like flash copy. You can do a flash copy on the backup system with Mimics if you want to, and simply end the apply sessions with Mimics. You're still protected through remote journaling. The changes are still queued up on the target system. You can do a flash copy of that LPAR, and after the flash is done, you can bring the apply jobs back up and you're up and running again. But many people do target side backups with Assure Mimics. As I said, you can just end the apply job. It's easy. You can use regular tape backup technology, save while active on the Assure Mimics target side, and flash copy if that's interesting to you. So due to high uptime requirements, performing regular backups is challenging. So I'm going to leave you with this here. So we've talked about a lot of different things, and I did a rating system here, and we took all of these different things. The considerations and the real world scenarios that we just talked about are listed here, and you can take a look. I invite you to look at these and do your own ratings, okay? And what you're going to find out is that Assure Mimics and logical replication is going to get a much higher resiliency score than these storage replication based resiliency scores. So you take a look at this, and if you have any questions, you give us a call and we'd be glad to dig in on that with you. So with that, Bill, I've covered a lot of ground here, and I'm going to turn it back to you for Q&A.
Okay, you sure have, Dan. Take a drink, take a breath. You got through a lot of information in a fairly short period of time. So thanks a lot for that. I hope everybody out there got a little bit of knowledge that they didn't have before and ways of looking at this storage versus software-based or logical-based replication choice that we all have in our IBMI environment. So do have time for just a couple of questions before we have to wrap it up here. So Dan, I'm going to have to throw these at you. Unfortunately, I'd love to give you a break, but what storage replication options are out there for IBMI? You talked a lot about Assure Mimics as the software-based replication, but what are the storage replication options out there?
Yeah, for IBMI, the ones that I've seen most are, of course, the IBM storage. they have storage replication options, and then the other one is the Dell EMC storage. Although I did see an announcement that um, that may be changing. There was some kind of an announcement that Dell didn't renew the license agreement with IBM to support IBMI anymore, something like that. If you are running Dell storage, you might want to check that out, and verify that. But those are typically, now I think there's some other storage manufacturers out there that do. Typically, if you were going to look at the independent ASP, which, if as I said before, any kind of serious high availability disaster recovery solution, you would want to look at independent ASP. Full system storage replication is pretty limited, right? And it's not really strong. So if you're going to do an independent ASP, which you probably should do if you're going to go the storage route, then you're probably looking at IBM storage.
Okay, great. Last question here, and we could probably do a whole webinar on this one, so you're going to have to be summarize the point here. But are there scenarios where you would need both a software-based replication and a storage-based replication approach?
Oh, yeah, that's an interesting question, and yes, of course there is. And it's these are all technologies of IBMI that I've been talking about, right? Storage replication, independent ASP, flash copy, live partition mobility, remote journaling. Every one of those are IBMI technologies, right? And they're used in different ways. So logical replication is based on journaling, right? And storage replication is based on device storage replication. So the reality is that customers are out there using all of these things. And so my point today that I really want you to think about is, when you're talking about resiliency, make sure you really understand what you're signing up for and what your expectations are and what you need, right? And you can certainly use, these are wonderful technologies, right? And they're complementary to each other. So just make sure that when it comes right down to it, when the power system fails, or the device fails, or the data center fails, that you are prepared with the best technologies out there, and you can switch and keep your application running.
All right, great, Dan. Thank you very much for that and all the other knowledge that you shared today. Thanks everybody out there for taking time out of your day to attend this. We do appreciate it. We hope it was valuable. As Dan pointed out earlier, if you've got additional questions on any of this, please reach out to us. You can contact us through the website with our contact us form that's available there. Or obviously, if you've already got an existing relationship with somebody at Precisely, give us a call, shoot us an email. We're here to help. And hopefully we can connect with you in the very near future, and hope that we see you on our next webcast. So Dan, again, thanks very much, and have a good day, everybody.